Hey, Lost Dragon Metals here. Today I'm doing some scrapping. That is of a couple of power drills, batteries and the chargers for them. Should be a good amount of stuff inside of all of this material. Nickel cadmium batteries in there, not of too much use, they're probably dead. And these are burned out from overuse. And they're also really old and smelly. But the motors in them will have copper. A heavy amount, along with other components most likely. We'll find out what. Got a nice angle here. Cool. Side, drill first. There's actually a screw hole down there, if you can see that. Let's get the top off. So do that first. Assuming I can undo it. That's not going nowhere easily, that. See why this is an issue. Do need to get it. That closes it. Don't want that. Pull the screw out. Got it? It's chewed up inside there. It's going to be a nightmare to get that one off. See that screw inside of there? It's locked tight. I do need to get to that to get to the screws underneath. Do the ones on the side. We'll be able to get to it from there. Using a flathead screwdriver here. There's better grip on the crosshead screws generally. Longer screw, felt like. This is a 600 RPM motor. So it says. Screw still stuck in there. There we go. Seems to be a smaller diameter of screws on the handle. That's unusual, unless one of the or two of these screws have been replaced. It looks like some of them have, they don't match. Maybe this was an old screwdriver to begin with. Yeah, these screws are mixed up and different. I think this may have been taken apart before. Odds on. Builders and such do that. Okay, one more screw left here on the base. They're all done very tightly up. All the screws off that. Oh, plasticky. Do not want. So what do we have here? That's most of the plastic, that casing lot. Nothing interesting to that. What do we have here? Nice chunk of, looks like zinc aluminium here. Judging by the weight, which is serving as a heat sink for this power transistor. There's also a large blocking diode there. They have a variety of uses as they stop current drawing back into things. There's also have a high voltage switch here, which is, you know, sort of interesting. Not sure what that thing does. Might be the lock. What does it say on there? It's a 15 volt DC 10 amp switch. We got a 10 amp switch there. Useful. Also, you know, don't find one of that higher rating every day. So I've got a big chunky motor here. This weighs quite an amount. 12 volt at that. People make things like CNC machines and things like that out of these. Usually with this end piece, however, which I am going to be taking out. As the front screw does appear to be jammed, and I won't be making no CNC machines with this. It's purely for metal scraps. Although I will test the motors, and if they do indeed work, they will be up for resale. I sell large boxes of motors. They are good for robotics projects and such, because they're usually quite expensive to buy new in any quantity apart from those toy crappy ones. Used in everything can usually break. Ooh, you got nice gears here, covered in grease, but nice gears. So we'll be keeping more plastic. That aside. Oh, there's an interesting mechanism. Look at that. But I do want these gears. I also sell these, and have before, a few of them actually. So that's a heavy chunk of steel there. Some bearing built inside, and it's covered in grease. Fantastic. So I'm going to put these back on and put that back in, otherwise it's going to all fall out. Well, a cool gearing mechanism. That's steel, that is. Some high carbon steel. Lots of bearings loose in here, see that? You know, these little bearings. We have ball bearings from the drill, which are obviously useful and pretty cool. Ball bearings are always cool. Well, I don't know. I think I mean, the process that made them spherical in the first place. Crazy. Metal working. Very greasy work. Lovely. So I can get that out of there. If not, I'll move on to the next one. Or actually another component probably. This is all gears, as you can see. And grease, there's loads of grease underneath there, I can see it. Lovely. Just fell straight out that, and it is absolutely caked in grease. I'm gonna have to get something to wipe this off me. It's nasty. Look at that. That stuff's definitely not good for you. Not so nice. Bit of tissue, wipe that off as I'm going. Yuck. Some nice big bearing inside of there. I would actually want that out, but I need pliers to remove that, I believe. Don't see any more screw holes. So there's the two on the front inside of here, as you can see, but I need to get that one out in the middle. Try again. Just about caught that. I can't get that screw to go anywhere. Might be locked in from the back and require this bearing and that to be removed in the first place. Well designed. Whew. So we got a 12 volt charger I'll be giving now. See what's in that. Some got that big motor out of there. Big chunky 12-volt drill motor. 600 RPM. That'd be great for a dynamo for a bike, for example, if indeed it runs, which it probably does. Could be one of these mechanisms that are burned out, one of these components, the transistor or even the blocking diode that's burned inside. Have to be checked. Ooh, we got horrible hexagon screws on this 12-volt charger. It's not a 12-volt charger, it's a 14.4-volt charger. One of them exotic drill types of voltage. There is almost no use in practical stuff, like if you charge a car battery. Plug here, which contains some copper, brass and fuse. The fuse contains a very small amount of silver inside of mains fuses, and there's copper in the wire. That's not good. That's not, just chewing that up. That's not working. Bigger one. Leverage. It's one of them thread screws. They're never good for opening. Put that in the screw pile. That other drill aside for now. Very nice chunky motor, that. There's some components. Grease. Where's that taking? Keep forgetting about that. Doing this plug at the moment, so I can show you what I was on about, the brass. So here we have brass on the plug ends, always of value. Yes, I know, it looks a bit like gold. No, it isn't. Brass is still quite valuable, so worth collecting. These things are also brass inside of plugs. These fitted in, but you would need to destroy the plastic to get to that, so I'll put that aside. Fuse, probably still functional, however. Doesn't appear to be anything wrong with it. And it's not rattling, so the filament inside is likely unbroken. Bit more brassy bits of this. And screws. These actually, I don't believe, will remove. There we go. This is plastic coating on the brass plug ends. It's pretty difficult to remove. Just got to sort of carefully score it with the sharpest blade you've got. Nearly always cut myself doing that though. Do want all these screws out. Screws are also useful always. That one is stuck. Trying to push it in with my finger. Oh, I got it. It's coming out. There's one of them partial threaded types that's not threaded all the way down the screw. It can be annoying to open. More brass from the plug end. So, big charger. There's also more brass there. Get to that. Trying to cut myself on film again. Nice little pile of gubbins and electronics piling up. That's a 12-volt charger there. That could actually be of use, the circuit in there, assuming it's not burned out. So we have unusually a single triangular screw here. Look at that. Well, my nail's nasty. Oil and goo, but the rest are crosshead types, so it will be easy to open. But that last one, I'm going to have to use the flathead on that and just open it with difficulty, I suppose. Turned on doing a few scrapping videos. I'm taking a little break from doing eBay listings regularly. Check out the description of this video for links to my eBay. Hundreds of items on there. And we'll be putting more on that in time. That's kind of chewed up. Yeah, that's completely chewed up, that screw. Almost rusty, may have to rip this casing off. Some of these screws are abnormally long or sharp. Right, try and open that one that's chewed up with this flathead screwdriver. That could sometimes work. The screwdriver itself is rotating. That's not going to work. Can do the triangular screw, however. Tip for you: you can open these nasty triangular, like sort of hex screws, with flathead screwdrivers. I'm going to have to snap this case since this last screw is totally chewed up. There we go. Nice, satisfying crack of plastic. Anyway, we got some connectors here. I need to poke them inside, all of them, and pull this board out. Nice circuit board. And this 14-volt charger. More than I expected on this side. Got a nice sizable transformer, some resistors. That resistor's blown. Look at that, it's burned out. Most definitely the source of the malfunction. So this charger definitely did not work. Got a couple of capacitors. These appear to be in good condition and unblown. There's a 400 volt capacitor there. That's semi-useful for high voltage products. Two transformers. You can see already. You can easily see the copper there. Got a capacitor here. This is one of those mono capacitors that only go one way. Not bipolar capacitors like these ones are. They go positive and negative. This just goes to positive, so one. And AC voltage is at that. 275 volt, yep. These are the ones you can make tasers out of. We have a video on that somewhere. We got a thermometer, I believe, to tell if it's overheating. Ceramic covered one, or it could be silicone. Probably silicone. Toroidal bead transformer here, this thing. Can make dual feeds out of them. What they sound like, suck battery dry. Big fat chunky blocking diode, always useful. A few capacitors. These things can contain tantalum. I think the brown ones are better than the blue ones, if I remember correctly. Nice aluminium heatsink there, and a looks like a power transformer. Yep, that's a power transformer. I think it says L32. It might actually be some sort of voltage regulator. Got an optocoupler here, that tiny little square thing, which is basically an electronic switch. Little transistor there. And what else do we have on the back? Ooh, a couple of microchips or microcontrollers. Can't really see the name on them or the make. Probably some sort of microcontrollers for the charging circuit though. A couple of germanium diodes, that's what these are. Zener diodes they're called, but they contain the material germanium used in night vision optics and modern night vision camera phones and such. These brown things contain palladium. They are MLCC capacitors, and these are resistors. Massive amounts of these, like a bucket full of them, contain very small amounts of super rare materials like ruthenium. or even more exotic stuff like osmium, really dangerous stuff. Not to be messed with, these chemicals. And all this solder contains tin, antimony, and sometimes small amounts of silver. Doubt there'll be too much silver on that circuit, however. Just rip these wires off. There we go. Circuit board. Another chunk of waste plastic. That plastic can be recycled. If you've got a 3D printer filament machine, you can chip up that plastic and turn it into 3D printer filament. Oop. Lower the angle of that camera slightly. See more of the circuit boards and other stuff. Scrap it is generating. Battery now. These are the ones with the power indicators on the front. Now the battery inside here will be nickel cadmium, which is no good. So as it can see on the front, it says NiCad, which is nickel and cadmium. Now cadmium's extremely bad for you, so I'm not going to be getting any of that on you. It's a sort of sulphury like material and colour, so it's yellow and exceedingly toxic. So one of the metalloids, which is just not good for you generally. It's not the kind of metal that I'd melt, or alloy that I'd melt into my metals anyway. Even though you can have like cadmium silver in jewellery, old jewellery. However, it was known to cause things like skin irritation and that, so due to it being mildly poisonous. But if it gets into you, like mercury, if mercury gets into you, you're doomed if it gets into your blood. It's like, can't really get a liquid metal out of your blood easily without giving you a full transfusion, I guess. Anyway, enough metal talk. Ugh. Also got a few other things to do. Take apart new stuff. Some bigger pieces and smaller pieces. Things I haven't torn apart before. What the hell's going on with this screw? Some of these are chewed up for weird angles. So I'm going to be using the bigger screwdriver. Do not bin. Do not set on fire. Do not put near fish. Okay. That's the cadmium, because cadmium would leak into the water source and kill loads of stuff, probably. Cool. Right. Oh, that's weird. How's that open? Right. Well, that is corroded quite a lot. Nickel cadmium batteries. Mingyan says on them. So definitely a Chinese make or Asian of some sort or whatever. Oh, there's a circuit board under there for the battery checker. Now that can be useful. I do want that. So let's get the batteries out of here. Seems to be a sort of plastic battery holder there. That could be semi-useful. Don't think these nickel cadmium batteries are actually worth much, to be honest. You're probably weigh in a massive bucket full of them or some such. But I don't think you get much for your money. Nickel, however, in them is worth money. So it'll be probably in the value of the nickel. Because cadmium's not so good, as I said. They'll still pay for it. If you've got enough weight, even the government will probably buy that off you. Ah, there we go. Plastic. Lots more plastic. So there's the battery checking circuit. Disconnect that, that'll be useful. I do want this, as there's likely very little that can go wrong with these sort of battery checking circuits. I have a few, as they're always useful. It's one of the ones with LEDs and a push button. Right, fair enough. And more to the circuit under there. It's got positive and negative marked on the circuit board, so I'll just tear that off. I can either keep it or use it for scrap. Put that battery bank aside. So, big pile of materials gathering. A bit wobbly there, sorry about that. Because I'm handling the phone by hand. A nice chunky motor. You can see some copper straight into there. And some brass. Ugh, grease. Not that that's a benefit. Wire from the mains wire. There's a little bit of brass on there also. 12 volt charger now, and then got that last drill. Might as well do the other one. Weird angle there. There we go. Big pile of plastic generating. Only 3 screws to this big thing. It's not a large charger. It is 12 volt, however. Although I wouldn't recommend you charge like a car battery or something from such a small charger. You probably burn this up. Besides, I tend to charge such batteries with just solar panels, some of which I've salvaged. So, free power with free solar panels. Right, there's a nice circuit board inside of there. I like them colours, circuit board colours. Big blobs of solder onto these connectors here. That'll have to be sponged off or sucked off with a solder vacuum. Show how to do that in one of my videos. Look through my playlists and you'll find all my scrapping videos. So I've got a couple of resistors, a few resistors, 4, and a couple of transistors. 2. A nice red LED also. That probably still functions. Same as the most solder, this contains probably antimony and tin. Sometimes it contains silver, but generally these days that's kept for things like PCs. They nearly always have high quality silver solder. Sometimes even they mix a tiny amount of gold in. So I've heard. Unless that's a myth, but I doubt it. Would help the conductivity. Oh, this is a heavy battery, this one. Quickly get through this. Doubt there'll be any circuit inside of this one. I've got to take them apart. See what's what. Don't think there's a circuit, as I say. There's no lights or buttons or any charging ports here. Maybe some protection board inside. I don't think so on these old style NACAD batteries. They're pretty crappy. They don't last long. I should use lithium batteries. Yeah, I thought so. The battery bank has no circuit board, as you can see. Another nickel cadmium battery bank. What do we have here though? Oh, we do have a temperature sensor. Yep, we have a temperature sensor inside of the nickel cadmium circuit. Well, at least that's something on it. On the battery bank. Fair enough. Was worth tearing down, I guess. Ooh. These jewels are actually quite weighty, as you'd expect. Let's lower the angle on this a minute. Sorry about that. Get back to the Teardown. Same routine as last time. A bit quicker with the unscrewings though. As I said, I sell quite a lot of the good materials that I salvage. Ones are in good condition and tested and such, or ones that just don't break. Things like stereo speakers, very little that can go wrong with them unless the comb is burst through. The diaphragm on the speaker. Anyone? No? I've done all the screws already. Well, see if I can do the one in the middle. Down there. The last one was unsuccessful. Wow. Okay. Instead, my phone gimbal stand thing fell. Not the plan. Going on one of the legs on this. I'll go and skew it since it fell. Shh. Okay. That did not work with the screw inside of there. Stuck fast inside of there. I'm pretty sure the inside of the things are falling off the table. Inside of this gearing mechanism is where the release for that is. What's going on here? I missed a screw. Don't think so. Oof. It's proper fastened together. Try and grip it open. Oh, come on. Is that a screw underneath this plastic crap? Okay, that stuff's really weak plastic. But I also got a feeling it's holding that in place. There's the motor inside of there, exposed already. Lanyardy thing. Probably worth keeping that. I haven't missed any. Yeah, I have missed a single screw and it was under the handle. Oh no, there's 4 screws that I have missed that were hidden underneath that plastic handle. Phantom screws. Designed to screw with you. Literally. And figuratively, I guess. Yes, this is hard work. But I want to reduce the space of these, taking up in a box, and get to all the good materials inside, which as you can see there's quite a bit. Lots of copper, a few circuit boards, plenty of bearings and gearing mechanisms. Great for making something like a toy robot. Big piles of plastic. Okay, the entire thing just falls out. Most handy. So we got pretty much a very similar circuit in here. More antimonal solder, so tin and antimony. Another power transistor. and a big high power switch. Hitting all them. What's that thing? Oh, heatsink, aluminium. That it is connected to. And this is a 12 volt 16 amp 12 to 24 volt DC switch. So very similar to the other one. Doesn't stay in place though. It's like a single action switch. Supposed to be handy for high voltage things. It's a bit smeggy and burned, this motor. Strange sort of spring mechanism on this. Off. No. Come on. Spring. What's that? Just stuck upon it. A few screws on this, on the gearbox mechanism. Don't want to touch that, whatever it is. Black gunge. Looks like dirt and wood-filled grease. Fantastic. Drill teardowns are messy and full of gunk and disturbing colour oils. This is full of grease, I know it is. You can tell it's all leaking out. They're going to leak out. Nay, we're good. Oh, there's another one of them cool drill mechanisms. Very cool function to that though, isn't there? Nice motion to the device. There's another one there. I think I'll keep this drill mechanism as is, since I can't get to that anyway, and I still want to remove that in there, so I can find out if that's what's locking that big ass screw in place. Seems like it would be the case, doesn't it? Most likely. So another big motor. What do we got here? Well, a load of metal gears. Very cool. Metal gears just fell out of here. Look at them. Very shiny. Cool. Hard to destroy gearing. Always useful. Big pile of metallics here. Loads more metal gears, including a nice chunky one. Ooh, there's a nice weight to these, gotta say. Cool for remote control cars and such. Out. It's all very greasy. I want that out though. It's like a cool sort of gearing mechanism. Come on, out. It's sort of stuck in there by its own tension and grease. See that? Come on. I'll probably break one of the teeth if I force that, I reckon. Just broke off. Anyway, nice cool gearing mechanisms. Metal gears. Very, very smeggy, as you can see, with grease. But obviously quite useful. More protective O-rings, or what do you call them? Spacers, I guess. Put them aside. This is really unexpectedly messy. So I could get to that motor there, might as well do that. Since my hands are already covered in grease, might as well get this over with. These motors have to be tested anyway. Low current of 12 volts run through them, see if they work. Although, you know, it feels quite functional, so like it's okay. And don't see no remarkable wearing or tearing inside. These would make great boat bike dynamos. These would pedal bikes, charging batteries for your lights and such. Comes off on the other one as well. It's just spaces. Well, I'll take that one off in a minute. Look at that. Whoa. Now that is oil. Right. Nasty. Big pile of plastic formed. Anyway, all done. And that's the materials that I'm left with. Some brass, lots of screws, bearings, the shafts of the drill. I've got a big battery bank of nickel cadmium batteries there. Some circuit boards, charging boards, protection boards and such. Some brass from the plug, fuse, probably functional, contains a tiny amount of silver, traces. A couple of big motors. If in fact these don't work, they contain a substantial amount of copper, which is of value anyway. And we also have these high voltage switches and power transformers, that are, transistors that are upon them. And some copper inside of the plug mains wire, which is good for making things like this. Copper trees. Or tree art out of copper. So, very interesting use for them. Anyway, see you in the next teardown video. Ooh, Lucky just come out. Let's have a quick look. My rabbit, Lucky. Okay, Lucky. Aww. Lucky says hi and bye.